Hi everyone, I hope you're hearing me and seeing me well. My name is Tiago. I've presented one of these seminars, the ones on E. coli, also on diagnosis and monitoring. So I hope that it's clear for everyone, and if you have any doubts, please don't forget to write it on the Q&A, and at the end we'll cover everything, every doubt that you might have on this topic. So on this presentation, I will talk about the laboratory analysis for Salmonella. I will give an example of how we control Salmonella in Europe, how is the monitoring program and how does it work, and how can we detect sources of contamination, how to deal with it, what to sample, that sort of questions that you might have. So the first question that it comes to mind is, why do we diagnose Salmonella? It can be for several reasons. In our case, it can be for the official monitoring program that we have implemented in Europe. It might be because you really want to know where does your Salmonella infection is coming from. If you find it at the final product, meat or eggs or wherever, or if you have it in your farm and you want to know if it comes from feed or from the day-old chicks, then you do a detection or a kind of serotyping to find where does it came from, so you can implement measures that that control Salmonella infection. Or it can also be for quality control retail, this more at the end product. How to sample it? Important here is that you have to think if you do want to find it or not. Why do I say this? Because of course on the official monitoring program you have consequences for having positive for Salmonella, which might include you have to destroy your eggs, or you have to take some more tight biosecurity measurements, and you might want to evade these sort of consequences. Of course, this is not correct and we do not advise it, but it's something that we do see in Europe. Sometimes, I don't think that that's often nowadays, but sometimes people try to evade the positive for Salmonella to escape the consequences, but of course this is not the way to go around it, and it will not be effective in the control of Salmonella. So here the question is that if Salmonella is not a question of finding it or not, is really if you want to find it or not, and if you take enough samples to be representative or not. What tests to use? You have several tests that you can use. For the standard protocols, or the ones that the guidelines that we have in an official monitoring program, you have standard ways to control if you have Salmonella or not. Then you have fast screening tests, which can give you just the answer if you have it present or not, but they also can give you false positives or false negatives, and more specific tests like serotyping or genotyping, which allow you to understand which kind of strain of Salmonella you have in your flock or in your eggs, in order to trace it back, like I explained before. So, like Hilde explained yesterday, Salmonella is a gram-negative bacteria. We have more than 2,500 serotypes. It's important in poultry mainly because it's a zoonotic disease, but we also have host-specific Salmonella like Pulorum gallinarum, which give us signs and are pathogenic for chicken. So they're also important for our chicken as well. We also have the non-host specific Salmonella, which are the ones that we care about more, like the zoonotic ones. These serovars that I'm explaining, or these different strains, they are based on the Kaufman-White method. Hilda mentioned it yesterday, but this is just a type of classification which is based on phenotypic characteristics of Salmonella, which in translation means that we classify it on the outside or the surface antigens that we have in each strain of Salmonella. So it's basically classified with these 3 antigens. There's one more, but it's usually with the O serotype, the H, and the V antigen that we have at the surface of Salmonella. On the official national control programs that we have for poultry, in layers and broilers, we control Enteriditis in Typhimurium, and in breeders, several other strains that we have as well. Okay, this is a list of different strains that we have for Salmonella, depending on the antigen that they have on their outside surface. Like I said, this classification is a phenotypic classification, and we do a test for this serotyping classification, which I will cover, which is basically a test with specific serum that reacts with the Salmonella and allows agglutination of the strains and allows us to understand which strain do we have. And then we have these different strains that we have here on the list. So like I mentioned, Salmonella species are responsible for foodborne illnesses in humans, mostly Enteriditis and Typhimurium. Poultry products like egg and meats are the main cause of infection. And here the important part is really that animals are asymptomatic carriers of these strains, which, if we think about it, it's a really a thing that doesn't help in the control, because we really don't know just by looking at the chickens. And if we do, if we think about, for instance, in coronavirus, and if we think that we might have asymptomatic carriers that allow the chain of contamination to continue, but we really don't know if they are ill or not. So this is a very important characteristic of the zoonotic strains that we have. The microbiological analysis that we do in chicken, they can be done in several matrices, or foodstuff for human, like meat, eggs, and milk, so everything that that is animal-borne foods, or at farm level in fecal samples. That's mostly what we sample, but we will talk about that later on the presentation, and we'll see that it's not just fecal samples. And for instance, when we want to do a more detailed monitoring, we sample other things as well. There is a need, of course, for fast and reliable techniques. As I mentioned before, if we know, of course, the time that we will have between sampling and the answer, if we have a positive flock or not, will be crucial to take the correct measures at the correct time and to increase the effectiveness of our control. So we have, as I said, several diagnostic tests for Salmonella detection. The more traditional ones, which are culture-based methods, so in the lab we just culture Salmonella, and then the more alternative methods, the immunological methods, and then the typing methods that I mentioned, like the Kaufman-White, but also more on the genotype part, the PCR, and I also mention another one as well. So I mentioned here the ISO rule, so the ISO 6579. It gives us the guidelines for detection of Salmonella in food and animal feeds and animal feces, so how to culture them and how to detect if we have Salmonella or not. I will show in just a second what is the normal culture procedure. So Salmonella is a bacteria that doesn't grow so well, so it has to be pre-enriched when it arrives to the lab. So the first thing that we do when we have boot swabs or other type of samples that we might have, we put it in a bag with Peptone water and we let it stay overnight at 37 degrees. Then on the next day, we have to do an enrichment, which is made in selective medium that only allows Salmonella to grow. You have both liquid media and semi-solid medium. And after that, then you do a cultivation on another plate that allows only to Salmonella to grow and limits the growth of other tests. So after this cultivation, the plates that are suspected to have Salmonella, they are biochemically tested to give us for sure if we have Salmonella or not, and at the end, which strain of Salmonella do we have. If it comes to that, it might be that we only have positive or negative, but if we do want to trace it back, like I mentioned, important to know the strains that we have present. Of course, like I just show you the procedure, you can imagine this procedure takes some time. So to have a negative test or a negative answer, we have to wait 72 hours and 48 more for confirmation. So it's quite a bit of time to be sure if you have Salmonella or not present. Also, some other things that are important to mention: non-motile Salmonella like Pulorum or Gallinarum, they have to have adjusted methods to grow. So a different incubation time and a different enrichment medium to allows us to understand if we have present or not. And of course, this is a very labor-intensive procedure, which also will, besides the fact of the time, but it also will limit the amount of samples that we can process on the lab. So this is just to say that it has his limitations, his methods, but it still is an official standardized mode and is accepted worldwide. And it's the one that is used for official screening programs, like the one that I mentioned in Europe, which I'm going to show just now, the general guidelines of the program that we have in Europe. We have also other ways to see if we have Salmonella present or not. An example is this chromogenic media. It enhances the speed and accuracy of the results. It's easy to read. Basically, what it does, it has a specific color for Salmonella cultures. So in this case here that we can see, this is just an example. We have several ones, but in this one, Salmonella is the purple colonies. The only thing with this test is really that it still needs to be verified, so it doesn't fit on our official monitoring programs that we have in Europe. So like I was just saying, the ISO method, the procedure that I just showed, it's the golden standard both for Salmonella and Campylobacter. but it's still time consuming and labor intensive. It has some risks of false negatives, and the use of these chromogenic plates as a plus to the procedure, it enhances speed and sensitivity, so it could be also a nice way to know. We have also other methods, like I mentioned, some more quick ones that give us just the answer if we have it present or not. Still, most of these tests still need to be cultivated first. So it's not like you arrive to the farm with this plate right here, that it seems much like a pregnancy test or something like that. It's not like you put the feces there and it will give you the answer or not. So this is just to say that you still need to cultivate Salmonella and so on. So it's not that straightforward like it seems. Some techniques have increased sensitivity, but this just to show that you have other ways to see if you have Salmonella or not. This method is also not validated according to the ISO guidelines that I just showed. So it's not a validated method, and it's not taken in account in official programs. Okay, so a bit more on the typing of Salmonella. If you remember, like I was explaining, besides the fact of knowing if you have Salmonella present or not in your flock, if you do want to do a more specific trace of your strain, so if you want to know where did you might had the contamination, if it was from the feed, if it was from the day-old chicks, from the breeder flock, it's important that you do any type of these methods of typing Salmonella. So we have a phenotypic method, which is the case of the Kaufman-White procedure, like I explained, which are still the golden standards of this type of the typing of Salmonella. And then you have the molecular methods like PCR, PFGE, I will show you in a bit, which are more based on their genotypic characteristics. So it's like it gives you a fingerprint of each strain. Okay, so like I explained, this Kaufman-White methods, it's based on reactions with specific antisera, which means that Salmonella has still to be cultivated, so it has to pass through the whole process that I explained before, and at the end, you do this procedure, which you mix Salmonella with a specific antisera, and if you have agglutination, like what you have here, you have a positive result. Otherwise, you have a negative one. Still, something important to say is that false positives may occur as a result of weak non-specific agglutination. So important to have in mind that is not always right, but it's still the golden standard for typing of Salmonella. So like I said, you also have molecular methods. I'm sorry, I just said that Kaufman-White is the golden standard, but no, the electrophoresis is the golden standard for that. So the only difference here is that you still have to culture it, and then you add it to a buffer suspension and to an agarose gel, and you do an electrophoresis, and then you have a kind of fingerprint for each strain, and then you have an idea of which strain do you have in your farm or any other place that you might find it. You have also PCR, has a high level of specificity. You have different types of PCR. The most basic one, or the most classical one, let's say, only gives you the idea or the result if you have a specific strain present or not. And then you can have a real-time PCR, which gives you the amount of a specific strain in your sample. So one is more qualitative and the other one is quantitative. It still has to be cultured before and all the other things that I explained before. Okay, so now a bit on the monitoring programs that we have in Europe. This is just an example. You have several different programs, by the way. You have different one for the US, which have different guidelines and different ways to to deal with positive flocks and positive eggs and so on. So this is just an example of one of the monitoring programs that we have. We have seen, I think Hilda showed us yesterday, the results of our monitoring program and how successful it was. I will also show a chart of, in specific Portugal, just to show you guys how does it work and the effectiveness that we have been having in these monitoring programs. So it's a defined monitoring program. It's based on standardized protocols for sampling and lab analysis in all countries, which means that we have a guideline for the ways to sample, the days that we have to sample, how we should deal with positive flocks. So it's a complete procedure of monitoring during your rearing period, and also how to deal with your finished product. The EU approach is from farm to fork, so it's really from the start of the production chain until the end, until the end consumer. It controls breeders, layers, and broilers. This program, in this case specific for Europe, the way that it works is that they give us the main guidelines of the Salmonella control program, and then each country has the ability to adapt it to their own reality. The main guidelines cannot be changed, but each country can add, for instance, more controls, or basically, if you want to tighten more the Salmonella control plan, you can do it. If you want to, let's say, step 1 degree on the monitoring program, you can. So the guidelines are really the minimum that you have to have on your control program. So this program that we have aims to reduce Salmonella levels in poultry and prescribes a target for maximum Salmonella levels in broilers, layers, and breeders, like I explained. But it's basically it's based on increased sampling on the production and rearing periods, but also on environmental samples. I will show you in a bit, but basically boot swabs, manure, dust as well, very important. And like I explained, each country can adapt it to its own reality. So I will show you some examples of what is done with each type of production and each type of strain, with each type of strain. So for instance, if we have breeders positive for Salmonella, flocks are destroyed. In the case for layers, eggs are diverted or heat treated, so or destroyed or heat treated, but are banned for table egg markets. So they cannot be sold as table eggs. Sorry. For broilers positive for Salmonella, they get a different logistical slaughter. So basically what happens is when you have a flock for broilers, for instance, that is positive for Salmonella, what happens is that it's slaughtered at the end of the program. I know that in some countries you don't have slaughterhouses, so it's not really the same reality. But this is really just an example and something to know how some countries do it. So, for instance, breeder flocks, if they are positive for Enteriditis orthifimurium, the birds are marketed, which means that they are slaughtered logistically at the end of the slaughter day of the slaughter in that day, and at the end of that slaughter, if we have Salmonella absence in 25 grams of the meat, they can be slaughtered, otherwise the meat has to be destroyed. On the eggs, if we have a flock that is positive for Enteriditis orthifimurium in breeders, they are destroyed or pasteurized. Usually they are pasteurized, so it's a heat treatment. And with the day-old chicks, they are destroyed. On the specific measures for repopulation, basically what it does is that we have to clean and disinfect the house, that we usually do, by the way. And then the environmental samples have to be negative between flocks. And the next flock has to be vaccinated for S. enteriditis if it's the case. For all the other strains, they have less severe measurements, but they still have. So imagine that it's any other strain. You still have sanitary closure until serotyping, so until knowing which strain are you dealing with. You still have to follow some guidelines to improve your biosecurity measures. And in case of some serotypes, you don't have that many restrictions, both in the flock or in the eggs. In laying hens, it's more or less the same thing, but you have less limitations. So if you're positive for Enteriditis orthifimurium, birds can be marketed, meaning meat can be sold if Salmonella is not present in 25 grams of the meat. And eggs have to be destroyed or pasteurized. The repopulation measures are the same. And if it's any other serotype, it applies the same rules as before. Okay, for broilers and turkeys, it's basically the same thing. It's actually even if it is Enteriditis orthifimurium, the only thing is that they have a logistical slaughter, like I explained before, and then they have to be free of Salmonella in 25 grams of meat, which means that basically what this means is that the level of Salmonella that we have in the meat is not a danger for, it's not a zoonotic danger, let's say. So if you have a level that allows you to be negative in 25 grams, then you are good to go and you can sell your meat. So here, just an example, in 2007, they started this control program, and you can see the prevalence of Salmonella in breeding flocks, for instance, decreases a lot. Also, the sampling increased a lot. Of course, all the measurements that we take, and not only the sampling, but also the biosecurity measurements that we have on the guidelines, help a lot to control Salmonella. So here you can see breeding flocks, and here you can see layers, which came down quite a bit, and you can see really that that is working very well. This is until 2016, but I think it's I know that it really came down even after that. So just something to have in mind and nice to know. Okay, so coming back on the detection of Salmonella. So how do we detect sources of contamination throughout the poultry industry, and what to have in mind? So what should we look for? Where should we look for? And we'll just start now. So this control should be like what we do in the official program from farm to fork, which means that we go over the whole production chain at farm level, broilers, layers, and breeders, then a bit upstream, hatcheries, feed mills, and then slaughterhouses, and all the transports that we have from the breeders to the hatcheries, but also from the hatcheries to the houses. Important to have in mind that we have, of course, to have correct sampling methods and critical places to sample. As I said, if you don't want to find it, it's really easy to pass this phase and to have a negative sample. So what's the problem with Salmonella? It's an ubiquitous bacteria, like Hilda said yesterday, which means that we can find it everywhere, really. It has a wide host of, it has a high range of hosts and is very resilient, which means that the control, it's really difficult. And when we think about a farm and all the factors that we have coming into the farm, really, if you go back to the biosecurity principles that we preach, you can understand that combined with these characteristics of Salmonella, it becomes really difficult to control Salmonella, because you have several factors, risk factors coming into the farm that have a high contamination risk from the day-old chicks that you receive, from the bed that you have in your house, on the feed, the control of people. It's always very important and very difficult to control the transports that you have. So every vehicle that you have coming into your farm. Then the vermin control, as we saw, is also very important, and all the dead birds and so on that we have in the farm. So this just to show that the characteristics of Salmonella combined with all the risk factors that we have in a farm create a very difficult to control situation, and that it's really an effort of all things that makes effectiveness and not just sampling and monitoring. So as we know, Salmonella can be transmitted both by vertical and horizontal transmission. Vertical, so from the grandparent stocks until your farm or until the slaughterhouse, if you want, and horizontal transmission, everything that comes in contact with the birds or with the end product like feed, hatchery, things that you have in contact with your eggs and so on, all the things that come in the chicken houses, also at processing level, very important, and all the things that you have to be aware at kitchen level. So something very, very important to understand. So this monitoring should be throughout the poultry chain. We should do this tracking and tracing from breeder flocks to the end, as I mentioned, both in egg and meat. Hatchery and processing plants have a high risk of contamination. So if you want to find Salmonella, as I mentioned before, really the important key takeaway here is to take a lot of samples, more than the ones are legally required. If you are under an official monitoring program, and keep all data of this sampling and so on in a database. Also, something very relevant is to have tracing numbers for each flock, both for breeders but also broilers, at eggs as well, because it allows you to understand which flocks did these eggs came from. For instance, what was the trajectory of this flock, where they came from, really to understand how did your birds get contaminated, and to do an effective tracing back of your positive samples. Okay, contamination, transmission route, serotyping, genotyping. As I mentioned before, if you do know the strain of your Salmonella, it's really easier, or it facilitates the process of finding the contamination routes that you had, and avoid false negative results. So this just to mean that if you shouldn't try to go around the system and have false negative results, because it's really a waste of time, money, and it's not really something that it will help you in the future. Okay, so here just an example of a case where you found at the final product level Steffenberg and Infantis, so at the slaughterhouse. And if we do have a monitoring and tracing program implemented, what we'll be able to see is, for instance, at the farm level, we still have Steffenberg and Infantis, but then we also monitored feed, and we knew that we had Infantis from the feed, and we had Steffenberg at breeder level. So this is just an example of the efficacy of a monitoring program if you do this kind of monitoring and serotyping in your program. So every step of production should be monitored, and to allow to trace back each contamination. Okay, I covered that. So types of sampling material that we can use. So peptonized cloths. We can also humidify these cloths with peptonized water, the same one that I mentioned for the culture of Salmonella. Sponges, swabs, overshoes on the chicken house, overshoes as well. Important is that you don't have impermeable overshoes, so a material that allows you to absorb feces, so otherwise it's not effective. At feces, cecal droppings as well. We saw yesterday that Salmonella grows a lot in the cecas, so important to when we are sampling to catch cecal droppings. And then at the hatchery, also several things, box liners, but also ventilation. I will show you in a bit a checklist of things that you can sample, also for cleaning and disinfection, things that we should look at when we are searching for Salmonella. Okay. Important thing here to mention is that we shouldn't, when we are doing this kind of monitoring, we shouldn't do only one sample. So it should be really an effort to do as much samples as you can. Also, if you do pooled samples, it's a nice way to have several surfaces in the same swab, for instance, but really important to mention that Salmonella is easy not to find, and only one swab really doesn't get you anywhere. So you need a lot more samples to find it. So each sample should contain at least 25 grams of organic material. The sample material could be, as I explained before, a peptonized cloth or sponge or swab. We should wear gloves to avoid contamination of our sample, and identify each sample that we have, so it's easier for us to, again, trace back everything and to know where we sample it, to really to have I think the important key takeaway here is to have a way and a system to trace back everything. So again, an easy way to get 25 grams is make pooled samples, which means that with the same material, you sample in several places. Samples should be visible and dirty. I don't think this is a problem to have in a poultry house. So really, if you have a cloth and if it's not dirty and you just sampled a poultry house, you were not effective enough. So just think about like you're cleaning the surface, and I think you'll be fine getting your cloth dirty. So sampling places, really cracks, everything that doesn't have much access when we are cleaning and disinfecting. Cecal droppings, also very important. As I mentioned, Salmonella is colonized in the ceca, so important to have that in mind. I will show in a bit some examples of cecal droppings. Yeah, again, on the overshoes, they need to be enough absorbent to be effective, so that we do an effective sample. Basically, what you do is that you arrive to the house, you put on these boot swaps, and you walk through the house back and forward, and that should be enough. Okay, so on the cecal droppings, they are thicker and stickier than normal, and also they have a stronger smell. But it's something like this. They can go from yellow to black, so you have, but they are usually more liquid, let's say, than the rest of the droppings. But it's important that we do know how to identify them in order to correctly perform the sampling. So as I was mentioning, you have here a list of the places that you should check when you are doing an auditing for presence of Salmonella. Important to mention here some things that have access, for instance, both to the interior of the house and the exterior, like the egg collection system, for instance, the ventilation system. So really to understand where is the key places to sample. So here, for instance, on your broilers, you do already, if you do have an official monitoring program, you do already the control while they are in the production phase, in the rearing period, let's say. But also something important to have and to monitoring, for instance, is the box liners, is the paper that you receive below your chicks, because then you know if you don't have any trace back to the breeders, for instance, then you'll know if you control your box liners, you'll know if they came from the hatchery, for instance, or if you can already take some options out of the table if you do know if this is positive or negative. But you have, of course, several other places that you should sample in a farm. Okay, here on the part of cleaning and disinfection, but here I think the important thing is really the usual cleaning and disinfection that we do, and to focus more on cracks and all the things that we usually don't clean as well. That is important to have in mind. Here, the important thing that I wanted to show you guys is that dust is a very nice way of Salmonella to pass by us. So dust, as we know, is very present in our production system, from the feed mill to the hatchery, and to our farms. So important when we sample it is to sample dust. Is also a nice way to have a complete. So dust is it's very it gives you a broader chance to know if you have salmonella or not present in your farm. Hatchery, again, important to have a system. So planning, tracing, tracking and tracing. One database with all breeder flocks and all their salmonella status. Have a unique ID, as I mentioned before, for every flock that we have, so we can relate the day-old chicks to the breeder flocks. Ideally, all breeders are free of salmonella, of course, but if we do know their status and we do know that they are positive for salmonella, we should separate eggs that we know that are positive for salmonella and ones that are not. Okay, so these are the same lists that I showed you before, but this is for the hatchery. Here, as you know, you have a lot of fluff and ventilation. It's very important here. And there is a place in the hatchery which is called plenum, and it's a central of ventilation, so all air passes through there. And that's a nice place to sample when you're doing control of salmonella. But you have, again, you have several places that that it's important to control. But you'll have this presentation anyway. So so if you do have any doubts, you can just come back to us and we'll clarify. So this is some examples in the hatchery. So really try to sample in the places that you know that cleaning is usually not done as effectively as usual. So below doors, the fluff sampling is also important. The bottom sides of the trolleys, for instance, the hatchers. So really everything that the plenum that I was mentioning just now, the box washer. You can imagine if you have a contamination of this machine, both water or machine, it will not clean your boxes. It will just help in the contamination chain that we have. Okay, so more examples that we have here. Fluff, as I mentioned before. Okay, so now a bit on the feed. 3 major important factors to have in mind is to understand the salmonella problem. So where to sample and how to sample. That we are sure that our pasteurizing heat treatments work well. So if they have, if they are effective controlling salmonella, and if we have any recontamination in any place of our feed mill. So important to have a system that allows us to sample the raw materials that we receive in the feed mill before we start using it. In the production line, everything from silos to mixers, elevators, so everything that we use as in our feed mill process, it's important to sample. Also ready products and at farm level, environment, birds, rodents, and dust. But this I mentioned it before. Okay, so here you have, as we had for the farms, we have a list of places that we should look into it. And in feed mill, if in the farm dust was relevant, you can imagine that in the feed mill you have a lot of dust. So really, the important key takeaway here is really that you should control all the places that we have on your system, so on your line, on your production line. Also, places that usually are dirty. I have here an example of metal catcher, but also, for instance, the pelletizer. You can see that that they are not properly cleaned. Also, an example of a cooler. You can see here that it has really a thick layer of dust in it. Also, silos, as we know, very difficult to clean effectively silos, and something really to have in mind. Salmonella contamination is usually low, no more than a few percent. And what happens in feed mills is that dust samples are much representative for a batch than the feed itself, because it represents a much more broader sample, let's say like that. I have here a chart where we can see, this is in Spanish, but this is different places of the feed mill, but you can see here that salmonella contamination in raw materials, both in raw materials and in feed, so finalized product, is higher in dust, in sample dust, than in the feed itself. So really, just to mention the importance of dust as a sample material. Okay, so I think I'm within my time still. So the important thing that we have to, or that I wanted you to take away from this presentation, is that really the monitoring through the whole chain is key to control Salmonella. The diagnostic tests that we use should be adapted depending on our objective. So if we are doing an official monitoring program, or if we're doing a routine check in the farm, or if it is a quality control retail at the final level. The correct sample is the start of a correct diagnostic. Of course, as I mentioned several times here, it's really easy not to find it, so important to have in mind that we do have to do a lot of samples to do an effective monitoring. And at the end, but not less important, really understand what are the critical sampling places and sampling material for each part of the production chain. So this is what I had to share with you. I hope that I answered all your questions during the presentation. And now we'll have Q&A.
Yes, Tiago, thank you for your presentation. There are quite some questions. So you didn't answer everything. Yeah, what is the best drug to handle Salmonella in poultry?
The antibiotics, but we do not advise the use of antibiotics in poultry. I don't know if this is related to
the gram negative, eh?
Yeah.
Salmonella. So yeah, first of all, try to have a gram-negative spectrum. There are some antibiotics that we know have been used successfully, like endofloxacin, like sometimes trimethoprim sulfa. But as we mentioned, we do not really advise to with antibiotics, but I know sometimes it's necessary. But you can culture and do a sensitivity test. That's always better.
Also,
So the next question, Sampling from different sites like cloaca swabs, blood, bone marrow, or other sites, does it have an effect on your negative or positive lab results? And then on the sensitivity test. I think the next question is a little bit the same.
Yeah, I think it is.
Culture and blood
sample. The first one is really, like I mentioned before, Salmonella is easy not to find. So of course, if you increase the number of samples, you'll increase the probability of finding it. I'm not sure if this is the question, but I think it is. If you, of course, if you increase the number of samples, you'll have a higher probability of finding it. I think that's about it, or not?
I think mostly this refers to like if you do a necropsy or, but here in this case, I think mostly we take fecal samples. It can be a cloacal swab, yes, but not really this bone marrow or blood. In the case of zoonotic Salmonella, I'm not saying if you are dealing with Gallinarum pullorum, yes, you can do that, and you will be able to isolate it if it's there. Not maybe the fact that it's intracellular will not interfere with your.
You're answering again the blood already. Okay.
Yeah. Okay. So for Salmonella, is it not possible to undergo direct PCR before enrichment?
No, you have to culture it before.
Yeah, that's correct. Yeah, I think here there was a little bit a mistake or misunderstanding. Did I understand?
The PGFG, it's the gold standard for serotyping of Salmonella, not to test Salmonella. To test Salmonella, if it's positive or not, the gold standard is the procedure that I mentioned, where you have the pre-enrichment phase, the enrichment phase. That's the gold standard for the test of Salmonella, but for serotyping, it's the PFGA. That's the gold standard for it. Yes.
Well, I think the gold standard for the serotyping is still Kaufman-White, but with this technique, you can go further than serotyping, and you can even say in a farm you find Salmonella enteritidis. With this technique, you can see if it's all the same strain. So it's going further than just serotype. They're all Salmonella enteritidis, but some of them, it's more a genotyping, in fact. You can see that there are, on one layer farm, you can have several strains of enteritidis. And with this technique, then you can, again, find out if there are different contamination routes.
Yeah.
Okay. Then the next question, which kind of medium is better to culture Salmonella between blood agar and McConkey agar?
That is a very good question, which I cannot give you. They are both used. I don't know which one is better, but we can go back to you.
The blood agar is less selective, so, and Salmonella will grow. McConkey is more selective, but the difference will also be the way the culture looks on blood agar or on McConkey. Some types will be.
I think it's very.
So that is But the standard to follow, I think, is this method that we indicated. The ISO method is still the best. And those chromogenic mediums are very useful because immediately you can see, you have a color change and you can see this is a Salmonella. So that is very useful. You don't need to do a lot of other biochemical tests then. Next question, how can the temperature affect the quality of the samples during storage and sampling? yeah, storage and transport to the lab.
Yeah, the guidelines say that they should be sent to the lab as quickly as possible at room temperature. I guess that if you delay it for a very long time at very high humidity and high temperature conditions, it might affect, but there is no specific guidelines on that.
Well, I think you have to be careful with temperature and humidity, as you say, because Salmonella, and the reason why you do enrichment is that, in fact, Salmonella doesn't like to grow so you have to keep it in a good way. And the danger, if you don't keep your sample well, is that you will have overgrowth of other bacteria and you will not find your Salmonella anymore.
Yeah.
Next question. Is there any test recommended based on size of the flock, previous history, or infections of farms nearby?
Recommend based on size of the flock. I'm not sure if this is related to sampling methods or test itself. For test itself, I don't think so, no. For sampling methods, just the usual ones, the blood swabs and the clots they usually use, I think. But no, any like based on size of the flock, no.
Yeah, I think maybe the question is how many you have to take, or I think it refers a little bit, do you want to detect the Salmonella or for monitoring reason, or do you want to investigate deeper? So
Yeah,
as
again,
Thiago explained, the more samples, the better.
Yeah.
Is it true that fish meals in the poultry rations predispose to Salmonella?
Fish meal.
Yeah.
Do you want to take this one?
Yes. Fish meal, I know it's used quite a bit in Africa, and it can be meal, but sometimes it's really looking like fish. So I would say it's a tricky ingredient for Salmonella, because if it's very often it is dried on the sand or not in very hygienic conditions. You might have insects, rodents that contaminate. So yes, I think it's a risk ingredient. Although good fish meal is a good ingredient for poultry. But yeah, you have to observe, and sometimes just looking at it, it will already tell you a big story. If no one ever did any testing and monitoring for Salmonella on a parent stock farm or a laying farm before, where do you start? Which risk samples can you take, or do all of them? Start with cecal droppings. Okay.
If no I would say that you start at farm level. You start at, if you don't have any history, you will start at farm level, first of all, to know if you have a flock that is positive or not. And then from there, you design your monitoring program. But I think the first part would be the farm, and then go upstream for the hatchery, eggs, breeders, feed mill. But I would start with cecal droppings at farm level, yes.
Yeah. Which time are the samples supposed to be cultured after sampling?
Which time? The time between sampling and culture, here it's not more than 12 hours between collection of the sample and culture.
Yeah, I think the sooner the better, but if you can't keep it in good condition, then keep it in the fridge.
Yeah, indeed, you can do that as well. Yeah. Suggestion: could you give a session in the future on implementation of HACCP in poultry feed processing plants hatchery with emphasis on salmonella? Yeah, indeed, we do have a lot more information on this. We also have like a workshop on this monitoring program, so it's really like an exercise for everyone to know how to think or how to go around a monitoring program. But this was only 50 minutes or something like this, so we don't have time for everything. But tomorrow Hilda will continue with control.
So I'm very happy that you give us suggestions for new training sessions. So they are very welcome. Please do.
Indeed.
So I think this was the last question. Thank you, Tiago, for a good presentation. And I don't know if Eric wants to finalize.
Okay, thank you, Hilda, and thank you, Tiago, for the excellent presentation. It was 1 hour and a quarter, so we're all a little bit ready for tomorrow's last session. So I'm really looking forward and see you all tomorrow. Thank you for attending. Stay safe and wash your hands. Okay. Thank you.
Thanks, everyone. Bye-bye.
Bye-bye.